Welcome back, listeners. Today we're going on a deep dive into something we all know and love. Fat.
Oh, yeah, fat.
It's a topic that often gets a bad rap, but we're here to explore the science behind it, what makes it so delicious. And I was inspired by Cocktail Party Chemistry, episode 177.
A great episode.
It really opened my eyes to the chemistry that's happening in every bite of our favorite foods.
It's true, there's so much more to fat than just calories.
Right. So let's dig in. To start, can you give us a quick overview of what fat is from a chemical perspective?
Sure, well, when we talk about dietary fat, we're mainly talking about these things called triglycerides.
Triglyceride.
Yeah, and those are like the building blocks of fat. They're made up of three fatty acids attached to this glycerol molecule.
Okay. 3 fatty acids and a glycerol. Got it.
Yeah, it's kind of like a three-pronged molecule.
Interesting.
And these fatty acids can be either saturated or unsaturated.
Right. Saturated and unsaturated fats. We hear those terms all the time. But I'll be honest, I don't really understand the difference.
Yeah, it can be a bit confusing.
So what's the distinction, and how does it affect the properties of fats?
Well, it all comes down to their structure. Saturated fatty acids, they're like tightly packed together.
Okay.
And that makes them solid at room temperature, like butter, for example.
Makes sense. Butter is definitely solid at room temperature.
Exactly. That's because it's high in saturated fatty acids.
So what about unsaturated fatty acids then?
Well, they have these kinks in their structure.
Kinks.
Yeah, little bends. And that prevents them from packing together as tightly.
Ah, I see. So they're more loosely arranged.
Exactly. And that's why they're liquid at room temperature. Think of olive oil.
Oh, that's a good example.
It's liquid because it's mostly made up of unsaturated fatty acids.
So the arrangement of these fatty acids really dictates whether a fat is solid or liquid.
It does. And it also explains why fats have different melting points.
Oh, right, melting points. So butter, with its saturated fatty acids, has a higher melting point than olive oil, right?
Precisely. And that's why butter melts so beautifully on a warm piece of toast, while olive oil stays liquid even when you're cooking with it.
Okay. Now that makes sense. And I've always wondered about this. Why does chocolate melt so perfectly in your mouth?
Oh, that's a great example. It's because cocoa butter, the fat in chocolate, has a melting point just below body temperature.
No way. So it's designed to melt in our mouths.
It really is. It's like it was made for us.
That is so cool. It's amazing how these tiny molecular differences can have such a big impact on how we experience food.
It's all about chemistry.
But, I think we often focus on the texture of fat, whether it's solid or liquid. But what about the taste? How does fat actually make food taste good?
Well, for one thing, fat molecules can actually carry flavor.
Really?
Yeah, they act as these little vehicles transporting aromatic compounds throughout the food.
So the fat is like a flavor delivery system.
You could say that.
That's fascinating.
And then, as the fat melts in your mouth, those flavor molecules are released, giving you this burst of taste.
Ah, that's why a perfectly marbled steak is so flavorful, right? As the fat melts.
You got it.
It's like the fat enhances the existing flavors in the food.
Precisely. But fat also contributes to this thing called mouthfeel.
Mouthfeel.
Yeah, have you ever heard of that?
I think so, but I'm not entirely sure. What does that mean?
It's essentially how a food feels in your mouth.
Oh, okay.
Like fat molecules, they coat your tongue, right?
Yeah.
And that creates this smooth, kind of luxurious sensation.
I get it. It's like the difference between, say, a watery soup and a creamy, rich soup.
Yes, exactly.
Or like, a sorbet versus a really decadent ice cream.
There you go. You're getting it. It's not just the taste, it's that whole sensory experience.
The texture, the feeling.
Right. And fat plays a huge role in that.
Wow. I never realized how much fat contributes to the way we experience food.
It's pretty amazing. It's really quite something, isn't it? The whole world of fat.
Absolutely. But I have a feeling there's even more to uncover.
You're right. And, listening to Cocktail Party Chemistry, I came across some really fascinating facts about fat in our bodies.
Oh, do tell.
Well, in episode 96, they talked about how our livers actually have their own internal clocks.
Our livers have clocks. Wait, what?
Yeah, it sounds crazy, right?
A little bit. So is my liver, like, literally keeping track of time?
Well, not in the way we think about it, but it does follow a circadian rhythm, so its metabolic activity fluctuates throughout the day.
Okay, so my liver's working on a schedule.
You could say that.
That's amazing. So what does that mean for, like, how our bodies process things?
Well, it means the liver handles substances differently depending on the time of day, and that includes medications, too.
Oh, wow. I never thought about that.
Yeah, it's a whole field of study, actually, chronopharmacology.
Chronopharmacology.
Yeah, it's about how the timing of medication affects us. For example, some cholesterol meds work best if you take them at night.
So there's an optimal time to take certain medications? I wonder if that applies to food, too. Like, is there a best time to eat fatty foods?
That's a really interesting question, and it's something researchers are still exploring.
Makes you think, huh?
Definitely. Our bodies are so complex, and everything seems to be connected.
It really is incredible.
It is. And speaking of interesting connections, in the FDA, they have some pretty quirky rules when it comes to food and drugs.
Oh, I bet. I mean, they regulate so much of what we consume. There have got to be some interesting stories there.
Oh, there are. I learned a lot from cocktail party chemistry. For instance, in episode 92, they talked about red dye number 2. You know that one?
Yeah, I think so.
Well, the FDA banned it, not because it was dangerous,
Oh, why then?
because it looked dangerous.
They banned it because of its appearance.
Yeah,
Seriously.
I know. It's kind of crazy, but it actually looked a lot like another chemical that was harmful.
So it was like a case of mistaken identity.
Pretty much, but it does make you think about how perception can play a role even in scientific decisions.
For sure. It's not always just about the facts. It's about how things are perceived, too.
Exactly.
Interesting. Okay, so what other FDE quirks did you find?
Okay, so this one's kind of funny. In episode 95, they talked about how the FDA has this secret list of banned words for drug names.
A banned word list. What, like they can't use certain words?
Yeah, things like cure, safe, magic, those are a big no-no.
Huh. That's interesting. Why would they do that?
Well, it's to avoid misleading claims. They don't want drug companies promising things they can't deliver.
Oh, right. It wouldn't be good if people had unrealistic expectations about a medication just because of its name.
Exactly. It's all about making sure consumers have accurate information.
Wow, this deep dive has been a wild ride. We've gone from the chemistry of fat to the inner workings of our liver, and now the FDA's secret word blacklist. What else have you got?
Well, there's one more thing I think you'll find fascinating. It's about the link between fat and how our bodies process medication.
Oh, okay, tell me more. So fat and medication, huh? What's the connection?
Well, it actually goes back to what we were discussing about the liver and its circadian rhythm.
Oh, right, the liver's internal clock.
Exactly. That clock, it really influences how the liver processes things throughout the day.
And you're saying that fat plays a role in that?
It does. The type of fat we eat, it can actually impact how our bodies metabolize certain medications.
Really? I had no idea. How does that work?
Well, some fats, especially ones high in omega-3 fatty acids, they can actually affect the enzymes in the liver.
Enzymes.
Yeah, the ones that are responsible for breaking down medications.
Oh, I see. So like if I have a salmon dinner, that could potentially change how my body processes a medication I take.
It could. It's pretty fascinating, right?
It is. It really shows you how everything in our bodies is interconnected.
Absolutely. It's not just about the medication itself. It's about the whole system, what we eat, when we eat, all of it matters.
Wow. This is making me look at food in a whole new way.
It's pretty amazing stuff, isn't it?
It is. We've covered so much today, from the basics of fat chemistry, triglycerides and fatty acids.
Right, and how all that affects the taste and texture of food.
Exactly. Then we got into the liver's internal clock and even the FBA's quirky rules.
It's been quite a journey.
It has. But I feel like I've learned so much about how our bodies work, all thanks to that one episode of Cocktail Party Chemistry.
Cocktail Party Chemistry is a fantastic resource. They really break down complex scientific concepts and make them easy to understand.
I couldn't agree more. And for our listeners, if you're looking for more fascinating insights like this, I highly recommend checking out their show.
Definitely. And always stay curious. You never know what amazing discoveries are out there waiting to be explored.
Couldn't have said it better myself. Thanks for joining us on this deep dive into the world of fat. And until next time, keep exploring the amazing world of science all around us.